The graph shows how the velocity v varies with time t for an object undergoing simple harmonic motion. So what we see here is a velocity time graph. This is a minus sine curve. So let's just say that the equation for this curve is v is equal to minus sine t. The following graphs show how other quantities for the object may vary over the same time interval. So we have a cos graph here, minus cos, sine, and minus sine. Question 9 is asking us which graph shows how the displacement of the object from the equilibrium position varies with time t. Question 10 is asking us which graph shows how the acceleration of the object varies with time t. So we're trying to work out displacement and acceleration. So I know a lot of A-level physics students do A-level maths as well. So I'll first explain this using A-level maths. For those who don't do A-level maths, I'd recommend using this method as well, as you'll most likely find it easier. There's just a few things to remember. So the first is how to differentiate and integrate to go from displacement to velocity to acceleration and back. So to go from displacement to velocity, we would differentiate. Differentiate means find the gradient. You know that already. The gradient of a displacement time graph is velocity. In maths, finding the gradient of something often involves differentiating. It's a slightly more complex process, but it does find the gradient function. To go from velocity to acceleration, we would differentiate one more time, differentiate with respect to time, and to go back up, we integrate. So for those who don't study maths, if you find the area underneath an acceleration time graph, you get the change in velocity. Integrating does that. It's a mathematical operation that does that. Integrating finds the area underneath the acceleration time graph. That will give us velocity. This is the symbol for integrating. And we do the same thing to go from v to x. We integrate with respect to time. Again, that's finding the area under the curve. So we have sine, cos, minus cos graphs here. So we then need to know how to differentiate and integrate sine and cos. Let's start with sine. If we have a sine graph, that differentiates to make cos. Cos then differentiates to make minus sine. We have sine here. Sine differentiates to make cos. We have a minus sign in front. That minus sign just carries through. So minus sine differentiates to make minus cos. Cos differentiates to make minus sine. We have cos here, so this bit differentiates to make minus sine t. But we already have a minus sign in front. The two minuses cancel, and we're back to sine t, and the process then repeats. So going in this direction here, we are differentiating with respect to time. And going back up in this direction, we are integrating with respect to time. Okay, so how do we apply that in this question? So we have a minus sine graph here. We want to get displacement and acceleration. Let's start with displacement. We have velocity. To get displacement, we have to integrate. We have minus sine. Integrating minus sine gives us cos. So therefore our displacement time graph would be a cos graph. That is A. So the answer to 9, which is asking for the displacement time graph, is A. 10 is asking for the acceleration. So going back to what we have over here, we have a velocity time graph. We need to get acceleration. So we differentiate to get acceleration. We find the gradient to get acceleration. We start with minus sine. We differentiate that. We get minus cos. That is B. B is a minus cos graph. So the answer to 10 is B. You can also do this question by thinking about gradients. But from my experience teaching this, a lot of students find this conceptually quite tricky. So your best bet is probably to memorize this stuff here, the differentiating and integrating. That will be a lot easier. But again, I will explain it using gradients too. So as we were discussing earlier, and this is what you would have learned in first year physics in mechanics, the gradient of a displacement time graph is velocity. And the gradient of a velocity time graph is acceleration. So what that means is, if we have a displacement time graph and we find the gradient for that graph, again that tells you the velocity. In relation to the velocity time graph, it specifically tells you the y coordinates for the velocity time graph. So to reiterate, the gradient of a displacement time graph tells us the y coordinates for a velocity time graph. And similarly, if the gradient of a velocity time graph is acceleration, that means the gradient of the velocity time graph tells us the y coordinates for the acceleration time graph. So we have a velocity time graph. We're trying to get displacement for question 9, so we want to work backwards. This velocity time graph, the y coordinates for that graph tell us the gradient of the displacement time graph. So if the initial velocity value is 0, that means the gradient of the displacement time graph is also 0 to begin with. And that could be one of two options. That could be A or B. Gradient here is 0, gradient here is 0. Then the velocity time graph is a max negative value. This tells us that the gradient for the displacement time graph should be a max negative value. And that narrows it down to option A. The gradient here is a max negative value, whereas for option B, the gradient here is a max positive value. So therefore it must be A. I'll just do one more point as well. So at this point here, the velocity is 0, and therefore the gradient of the displacement time graph is 0, which again agrees with option A. And then for question 10 was asking us to get the acceleration. So the gradient of the velocity time graph tells us the y coordinates for the acceleration time graph. The initial gradient of the velocity time graph is a max negative value. So the y coordinates for our acceleration time graph should start by being a max negative value. The only option that satisfies that is B, but again I'll go through a few more points. If we then follow along on our velocity time graph, the gradient then becomes 0. Therefore the y coordinate on the acceleration time graph should be 0. The gradient for v against t is then a max positive value, and therefore the y coordinate for the acceleration time graph should be a max positive value. And that is answer B.